Hello, welcome to our third lesson on SPSS. In the previous lesson, we looked at how to perform descriptive statistics. In this lesson, we are going to be looking at data cleaning and data transformation. Before we dive into inferential statistics to draw conclusions about our population based on the sample data that we have, we need to ensure that data is clean and accurate, so that conclusions we draw about our population also be accurate. But one thing to note is that data cleaning is not only needed for inferential statistics, we also need it for descriptive statistics. And sometimes we don't even need to perform inferential statistics like t-test or ANOVA. Sometimes we just report descriptive statistics like the mean, standard deviation, and frequencies. And all these are affected by errors like missing values or outliers. So basically, these are the two things that do not make our data to be clean: missing values and outliers. So we need to detect them and fix them. So how do we do that? Let's look at how to detect missing values. So we detect missing values by performing descriptive statistics as we did in the previous lesson. So you go to Analyze, Descriptive Statistics, Frequencies. Then we select our variables here that we want to check for missing values, or we want to check missing values for. So I've selected the gender. I'm going to click on Ctrl A to select all, because I want to check missing values for all these variables. Now I'm going to move everything into the variables field. I can uncheck this one, but I'm just going to leave it. And I'll click on OK. So this is the output. The variables are here. This first table is summarizing everything on all the three variables. So it is giving us a summary of the number of valid responses and the number of missing. So here you can see that we have 20 valid responses. We don't have any missing value in all these variables. So by performing descriptive statistics, we'll be able to know whether we have missing values or not. So I'll go back to the data and try to intentionally include some missing values. I'm going to enter some values here. Enter. So now after entering these two values for the variable gender, SPSS is expecting that I fill the two remaining columns for the two variables here. So if I don't enter any values here, they will show as missing values. So I've intentionally included some missing values. So if I don't enter some values here and I perform the descriptive statistics, this will show as missing values. And even if I delete these values that I just entered, the male and the female, is also going to show as missing values. If I don't clear and I just delete them, you see some dot there, it's also going to show as missing values. Let me delete this one as well. Then perform the descriptive statistics again, and see that now we will have some missing values. So Analyze, Descriptive Statistics, Frequencies. Our variables are already selected. I'll click on OK. So now you can see some missing values. Now our sample size has increased to 22 because I entered some two new values. So now we have 20 valid responses for gender, 2 missing, 20 valid for age, 2 missing as well. And for the height, we have 19 and 3 missing. So what we are doing now is to look for missing values and fix them. And this table alone can give us the missing values. But we can also look at this table as well for the gender of respondent, which is a categorical variable, because we are going to correct these missing values. And for categorical variables, we input the missing values with the category with the highest frequency. So here the category with the highest frequency is the female. So anywhere there's missing value, we are just going to put female there, because in categorical variables, the most representative measure is the mode. So that's what we are going to do to correct the missing values in the categorical variable. But for the numeric variables, the most representative measure is the mean if our data follows the normal distribution. So you input or replace all the missing values with the mean of the data set if it follows the normal distribution. So let's go back to the data. So here for the categorical variable, the missing values, we can just enter the modal class, which we found was the female. So 2, 2. That is how we correct missing values for the categorical variable. But when it comes to the numeric variables, we mostly input or fix the missing values with the mean of the data set in that variable. So we've corrected the missing values for the categorical variables, but I'm not going to fix this one for now. Before we correct the errors in the numeric variables, we need to ensure that our data follows the normal distribution curve so that we can input with the mean of the data set. So last time when we checked, we saw that this one was not following the normal distribution curve. I did not save the changes, so this 376, which was an outlier, is still here. I can simply delete it. Or let's say I don't know and the data set is large, so I need to first check whether it follows a normal distribution curve so that I can input the missing values with the mean of the data set, because the mean is affected by extreme values. And if this extreme value is still here and I go to input the missing values with the mean, it means my data set is not going to be representative. So I can just delete the missing data here. Let's say I don't know there is an outlier because my data set is very large and I will not be able to just look through and see the outliers. How do I detect that there are outliers in my data set? So what you do is that you go to Analyze, Descriptive Statistics, Frequencies. Now I'm going to move this one out. So here we are only interested in finding outliers for the numeric variables. So the two are selected here. Here I want to check this display frequency tables because I don't need it. And I'll click on charts, and the appropriate chart for numeric variables is the histogram. I will check this show normal curve on histogram to see whether our data follows the normal distribution, and that is what I'm going to use to check whether there are outliers or not. So if there are outliers, our data will not follow the normal distribution curve. So let's see. So you see the histograms have been generated, and for this first one, because there's an outlier, it doesn't follow the normal distribution curve. So it's not only extreme values or outliers which do not make our data follow the normal distribution curve. Sometimes when we have small sample size, it will make our data not follow the normal distribution curve. And mostly it's outliers that does not make our data follow the normal distribution curve. So since this data is not following the normal distribution curve, it is telling me that there is an outlier. And I can clearly see that from here that most of the data sets are here, and I have some large values here, 400, and I have this bar here, meaning that there's an age value which is close to 400, and I don't expect that in the data set. So this shows there's an outlier. But for this one, for the variable height, we can see that it follows the normal distribution curve, as you can see this bell shape. So for this one, I can go ahead and input the missing values with the mean of the data set. But for this one, I need to correct or remove the outlier before. So I'll go back to my data set. Now I'll just delete this outlier. If the remaining data set follows the normal distribution curve, I can go ahead to input with the mean value. So let's check again if it now follows the normal distribution because I've deleted the extreme value. So Analyze, Descriptive Statistics, Frequencies. These ones are selected. When I click on the chart, I selected these ones already. I'll just click on Continue, click on OK. Now let's see. So this is age. We can now see that it follows the normal distribution curve, and this one also follows the normal distribution. So after finding out that the data follow the normal distribution, what we will do is to fix the missing values with the mean of the data set in this numeric variables. So how do we do that? We go to Transform, go to Replace Missing Values, then we select the variables that we have missing values. Here specifically the numeric variables. So we saw that we have missing values in the age as well as the height. So we select these two, move them here. So now for these two variables, after moving them into the variables field, you see that the age has been changed to age_1 equal to series mean. So this is the most used one, the mean. We don't mostly use the median since we assume that the data follows the normal distribution curve, and we need to ensure that before. So it is going to replace it with a series mean, that is the mean of the data set on age. So when I select only one, it's going to create this new variable in a different column here, and it's going to fix all the missing values. The series mean, I can change it if the data does not follow a normal distribution, but it mostly follows, or we need to ensure that it follows. So after that, we click on OK. These two additional variables were created. For age, we have age_1, and for height, we have height_1. So now when we are going to perform any kind of analysis, whether descriptive or inferential, we will not use the variables with the missing values. We will use these newly created ones where the missing values have been corrected or have been imputed. So for age, the missing values were down here. We had two missing values. SPSS calculated the mean, which is showing here as 44.11, and it is going to replace any place that we have missing values with this. So to use the data set we have here, the ones that are not missing, find the mean of the ones that are not missing, then replace the missing values with that mean. So here we're having these two missing values. For the variable age, it's calculated the mean to be 44.11, and it replaced the missing values with that. We had this place too as missing. Where the outlier value was, I deleted it, and it replaced it with the mean of the variable age, which is 44.11. When we come here to, we can see that the mean is 166.84. So it replaced all the missing values with that. So now we've looked at how to detect missing values and how to fix them. Here in the numeric variables, we input with the mean. With the categorical variable, we replace the missing values with the category with the highest frequency, which we found to be female. So data cleaning is basically about that, missing values and outliers. And we also detected the outliers using the histogram with a normal distribution curve on it. So let me show you another way you can detect outliers in your data set. Let me enter the outlier value we saw here again, which was 376. So let's see how we can detect that in a different way apart from using the normal distribution curve. You go to graphs, legacy dialogues, then you select box plot. So you use box plot to check for outliers in your data set, mostly for the numeric variables. So you select box plots here, then we select the simple, it's already selected. Then here we check this one, summaries of separate variables. So you want to check for separate variables, click on define, then put the variables that I want to check for outliers here. So let's say I want to check for age and then height, so I'll move them here. I'll just click on OK. So for this age, you can see that we have an outlier value here. Looking at the first box plot for the age, this one is for the height. So for the age, we can see that most of the data values fall in between or within 0 and 100. But this one is far beyond that. We have this one close to 400 and there's an outlier. And anytime there's an outlier in the data set, when you use this box plot, there's going to put asterisks there and tell you the row number. So here it is telling us that the row number where we can find this outlier is what? Row number 15. So we can go and delete that. But for this one, for the variable height, we don't have anything like an outlier. So that is how you can check for outliers or extreme values using the box plot. So that is all about data cleaning, correcting outliers and missing values. Now let's look at data transformation. So data transformation is basically about restructuring our variables and preparing them for inferential analysis, either recoding variables into different variables or creating new variables from already existing data. So let's look at how to do that. Let's start with how to recode variables. So we go to transform, then we go to recode into different variables. Now let's say the age that we have here, this time we are going to use the corrected one. Let's say the age that we have, we don't want the specific ages again, but we want the age to be in ranges. Maybe because you don't need the specific ages for anything again, but you want to put them into categories and find the frequencies. So we will need to recode this variable age into categories, thereby making it a categorical variable. So we move it here into this field, and a new variable that we are going to have, the categorical variable, we give it a name here. So let me say age group. Now I don't want the age again, I want age group. I'll click on change. So now we are going to create a variable called age group, which is a categorical variable from this numeric variable age_1. Now what we will do is to click on this one, old and new values. So here I will set my ranges at the left side here, and the values that I'm going to assign, I'll put them here. But before I even set the ranges, I need to have an idea of how my data set looks like. So I have age, I have 32, 33, 35. Okay, so I don't have any age below 25. So if I set a range below 25, that means I'm not going to get anything there. So the first range I'm going to set will be below, let's say 35 years, so that we can have some values there. So I can use this range option and say 0 to 35. But I can also use the second option, lowest true value. That means the value that we put here below the value we put here. So if I put 35 here, what it means is 35 and below, or let's say 0 to 35. So I can use this option to set the first range, lowest true value 35. I'm going to assign a value of 1 to that. Now click on add. Then for the second range, I'm going to choose this option since I'm going to use two values. So let's say I've set below 35. So let me say 36 to 45. I'm going to assign a value of 2. Click on add. 46 to 55. I'll give a value of 3. Click on add. Let me set the last category. So for the last category, I can just say 56 to maybe 70. Or I can also use this one, value through highest. That means from this value I put here and above. So let me say 56, and I will assign a value of 4. Click on add. So after doing this, if these are the categories I want, I just click on continue. click on OK, and you see that this age group has been created. So wherever it finds an age which falls into the category 1, it will put 1 there. So it has now become a categorical variable, and we can perform frequencies to see the number of people which fall within the age ranges. So for 1, it's 0 to 35. Then we have 3 here. Let's check the age, 46. So 36 to 45 was 2. Then 46 to 55 was 3. So you have 3 here. 4 was 56 and above. So you can see 4 here for the 65, 4 here for the 65, 2 here for the 37. And we have 2 here because the second range was 36 to 45. So after doing this, we can go and encode it here and say maybe 1 is for below 35 years. Below 35 years. So we do that for all the ranges that we have. Although when you leave it as this, it's going to show you that 1 has this frequency, 2 has this frequency. But if you encode it this way, you see that below 35 is maybe from this to this, and it will be easy to understand. So now we've also looked at how to recode. Let's look at the last one, at data transformation for this lesson, which is computing variables or creating new variables from existing ones. And this one, I'm not going to use this data set. You can use this data set to explain that. So I'm going to import a new data set. File, import data, Excel. So I've named that data student data. I'm going to open that. So these are the variables. We have a lot of variables here. I wanted the data to find out whether there's a relationship between study hours and test scores, and then this one is screen time and test scores. So those that have made SH are study hours, the STs are screen time. So I want to find correlation between these two variables, study time and study hours and test scores. So mostly data set like this, where we have variables like this, SH1, SH2, are mostly generated from questionnaires. So let's say I have 5 questionnaires. Here I have 5 questionnaires for study hours. So let's say the first questionnaire was I study at least 2 hours every day. And the options are going to be in a Likert scale form, from strongly agree to strongly disagree, where 1 is strongly disagree and 5 is strongly agree. So 4 will be agree. So if somebody chooses 4, it means that person studies. The person choose 1 or 2, it means that person does not really study or does not study at all. If he chooses disagree or strongly disagree. So for this one too, for the screen time, if the value is high, like maybe 4 or 5, it means the person's screen time, the person's usage of phone or the laptop for non-academic purposes is very high. So that is what it means. So now I have 5 questionnaires for each, and they are all talking about one particular variable. So the SH1 to SH5, they are all talking about one particular variable, which is study hours. So I need to compute this into one variable. Because they are all talking about one variable, I need to find the average for all these numbers. And how do I do that? I'll go to transform. I'll choose the first option, compute variable. Then I'll type my variable name here. So the new variable that I'm going to create, what is the name? So let's say study hours. Because the variable name cannot accept spaces, I'll use underscore study hours. Then I'll give the expression here. So here I'm going to find the average. And how do we find the average? I'm going to add all these from SH1 to SH5, then divide by a number of variables, which are 5. So what I'll do is I'll select this bracket here, and I'll double click on the first one to select it, and either click on plus sign here or use the plus sign on my keyboard. I'm going to use this one, SH2 plus SH3 plus SH4 plus SH5. So now I'm done with all the variables or the responses to the questionnaire on study hours. So what do I do? So after entering the last one, the cursor will be in the bracket like this. You have to bring it out. Use the division sign, divided by 5. That is how we find the average. And we click on OK. A new variable will be created. Let's see. So a new variable has been created here. And the average for each respondent can be found here. You can see the average for each respondent here. So now all the questionnaires on study hours have been computed into one, and most times you have questionnaires in our data set, and this is how we compute it, or this is how we transform it before we can use it for analysis like correlation or any kind of analysis that we want to do with it. So now I've computed this one. You can do the same thing for the screen time as well. Find the average. For the total too, you have to compute it. So because the screen time is going to follow the same approach, that is finding the average, I'm not going to do that because of the time. I'm not going to do that. So let me do for this one. This one we not find the average. For the test scores, we have test score 1, 2, 4. This one we just need the total. So how do we compute that? We just write the right expression for that. So I'm just going to delete this one. Type maybe total exam score or just use test scores. And I'll put the expression here. So how is it going to be? Test score 1 plus test score 2. Here we just need the total, don't need the average, plus test score 3 plus test score 4. And I'll click on OK. So this new variable will also be created. You can see it here. That's calculated a total for each respondent. So now we can use only these two variables to perform inferential statistics like correlation or regression. So that is that about data cleaning and data transformation. So we bring this lesson to an end here. Thank you very much. See you in the next lesson.